welcome back to Lucky Naresh Physics channel. Students, in this session I am going to discuss about electricity in class 10. In that I am going to teach charge, electric field, electric potential and potential difference. Students, when two bodies rub each other, what happens? When two bodies rub each other, due to friction, charge is produced on them. What is meant by charge? Charge is a fundamental property of a body. The SI unit of charge is coulomb. I said when two bodies rub each other, due to friction, charge is produced on them. We will observe some examples how charge is produced on them. Suppose if we rub glass rod with a silk cloth, then glass rod loses electrons and becomes positively charged body, and silk cloth gains electrons and becomes negatively charged body. Actually, here there is no negatively charged and positively charged body. For our convention, we consider if a body has excess of electrons, then it is treated as negatively charged body, and if a body has deficiency of electrons, then it is treated as positively charged body. Here, why glass rod only loses electrons? Why don't silk cloth? Because silk cloth has high electron affinity, so it gains electrons. Electron affinity means it is a tendency of an object to gain more electrons. Now I took animal fur and ebonite rod. Ebonite is a hard rubber. If we rub ebonite rod with animal fur, then animal fur loses electrons and becomes positively charged body, and ebonite rod gains electrons and becomes negatively charged body. Now we will discuss about properties of charge. Now I brought positively charged glass rod nearer to the another positively charged glass rod which is suspended with silk cloth. I observed that suspended glass rod is moved away from the glass rod which is brought nearer. Same thing happens with two rubber rods, both are having negative charge. Now I brought negatively charged rubber rod nearer to the positively charged glass rod which is suspended with silk cloth. I observed that positively charged glass rod is moving towards the negatively charged rubber rod. So we can say that unlike charges attract and like charges repel each other. This law is called laws of attraction and repulsion. Charge is additive in nature. Suppose if two charged bodies come in contact with each other, then the net charge is equal to the algebraic sum of the individual charges. Suppose plus 4 coulomb charged body and minus 12 coulomb charged body come in contact with each other. So net charge is equal to minus 8. So charge is additive in nature. Charge is conserved. Charge cannot be created or destroyed. It transfers from one body to another body, but net charge of the system remains the same. For example, here plus 4 coulomb charged body and minus 12 coulomb charged body both come into contact, then the charge is transferred from minus 12 coulomb charged body to plus 4 coulomb charged body. So each gets minus 4 coulomb. So net charge is minus 8 coulomb. Quantization of electric charge. The total charge of the body is always an integral multiple of charge of an electron. Q is equal to Ne, where N means number of electrons which is integer. E means charge of an electron. During rubbing, charge transferred in terms of integers from one body to another body. From Q is equal to Ne, we can calculate number of electrons in 1 coulomb charge, that is 6.25 into 10 power 18 electrons. What is meant by electricity? Electricity is a branch of physics which studies about various effects of charges. It has mainly two branches. One is electrostatics and the other one is current electricity. Electrostatics is a branch of electricity which studies about various effects of charges when they are at rest. And current electricity is a branch of electricity which studies about various effects of charges when they are in motion. Now we will discuss about electrostatics. When charge at rest, it produces electric field around it. The region around a charge in which it exerts electrostatic force on other charged particle is called electric field. To exert electrostatic force, charge need electric field strength. Force per unit positive charge is called electric field strength. E is equal to F by Q. SI unit Newton per coulomb or Newton coulomb power minus 1. Electric potential. For suppose I want to move 2 coulomb charged body towards 6 coulomb charged body. Here there is a force of repulsion. To move 2 coulomb charge, I need to do some work against electrostatic force. At any point, my work is converted into potential energy at that point. For suppose I want to move a unit positive charge from infinity to a point P which is in an electric field of a source charge plus capital Q. I need to do some work against electrostatic force. So here work done to move a unit positive charge from infinity to a point in an electric field against electrostatic force is said to be electric potential. So electric potential V is equal to W by Q or E by Q, where work done is equal to energy. SI unit joule per coulomb or volt. Okay students, now we will do problem on electric potential. If 80 joule of work is required to transfer 4 coulomb charge from infinity to a point, find the potential at that point. First we will write given data. Given work done is equal to 80 joule. Charge is equal to 4 coulomb. We need to calculate electric potential. We know the formula for electric potential, that is V is equal to W by Q. So if you substitute in the place of W 80 and the charge in the place of charge 4 coulomb, you will get 20 volt. Now we will do second problem. Calculate the work done in moving 2 coulomb of charge across a potential difference of 10 volt. First we will write given data. Given Q equal to 2 coulomb, potential difference V equal to 10 volt. We need to calculate work done. From V equal to W by Q, you can write W is equal to QV. So if you substitute in the place of Q 2, in the place of V 10, so we will get 20 joule. For suppose a test charge which is at position C, later it is at B and lost at position A in an electric field of source charge. Here A is higher potential and C is lower potential. Why here A is at higher potential and C is at lower potential? Because A is nearer to the source charge, at which it has higher potential energy, and C is far from the source charge, at which it has lower potential energy. Now I want to move a test charge from A to B in an electric field of source charge capital Q. For that I need to do some work. Here work done to move a unit positive charge from one point to another point in an electric field against electrostatic force is said to be potential difference. V is equal to W by Q. SI unit volt or joule per coulomb. In figure, A is at higher potential, B is at lower potential. So the potential difference between 2 points A and B is VB minus VA. For example, potential at B is 8 volt and potential at A is 3 volt. Then their potential difference 8 minus 3, 5 volt. To find potential difference in the circuit, we use voltmeter. Now we will define potential difference of 1 volt. When 1 joule of work is done to move 1 coulomb charge from one point to another point in an electric circuit or electric field is said to be potential difference of 1 volt. 1 volt is equal to 1 joule per coulomb. Students, in next session we will discuss about current electricity. Thanks for watching my video. Please subscribe and click the bell icon for all notifications. Thank you.